Hello students, so we are doing limits and derivative. Let's solve exercise 13.1. First question, you have to evaluate the following limits in exercises 1 to 22. Okay, so limit as x tends to 3, x plus 3. First you have to put this value. Okay, you have to see whether it comes 0 by 0 or any other not defined form. Then you have to go for the methods, okay, to reduce that form. So x plus 3, 3 plus 3 is 6. Okay, so no need to reduce that. Limit is x tends to pi x minus 22 by 7. So simply you have to put pi here. Okay, limit is r goes to L, pi r square. L or 1, it is 1. So in place of r you have to put 1. So the answer is pi. Okay, next question. Limit is x tends to 4. 4x plus 3 upon x minus 2. So when you put x equal to 4, it is 16 plus 3 upon 4 minus 2. Okay. Fifth question. Limit is x tends to minus 1, x is to 10 plus x is to 5 plus 1 upon x minus 1. So in place of x, you have to put minus 1. Minus 1 raised to 10 minus 1 raised to 5 upon minus 1 minus 1. So minus 1 raised to 10 means this becomes positive. This is negative. Again positive. Okay, minus half. Limit is x tends to 0. 1 is to 5 minus 1 upon x. Now here the problem is when you put here 0 and here 0, it will be 1 upon 0 type, that is not defined. Okay, 1 minus, this becomes 0 by 0 form. Okay, so now you have to reduce this. So here we can apply some formula. Okay, so we have to change this. What we can do? We can substitute here x plus 1 as some y. Okay, so limit also changes when x is equal to 0 here, then y tends to 1. Okay, so your limit changes to 1. And what about x? X becomes y minus 1. So you have to substitute. Limit is y tends to 1. X plus 1 raised to 5 is y raised to 5 minus 1 upon x is y minus 1. Okay. So this is of the form a raised to n x raised to n minus a raised to n upon x minus a. Correct? As x tends to a. So this is our n a raised to n minus 1. So n here is 5. 5, a is 1, 5 minus 1, so 4. which is 5. Okay, so final answer is 5. Next problem. Limit as x tends to 2, 3x square minus x minus 10 upon x square minus 4. So if you put here 2, it will be 0, correct? So again, this is of the form 0 by 0, so you have to reduce it. So looking at this, you will understand that this is quadratic, this is also quadratic. This is of the form a square minus b square. So we can find here the factors minus 30 minus 1, 6 and 5, minus 6 plus 5, correct? So 3x square minus 6x plus 5x minus 10 upon x minus 2, x plus 3, x 5, okay, plus 5. Okay, so this gets cancelled, you will get this thing. When x tends to 2, 3 to the 6, 6 plus 5, 11 by 4. Okay. Next question is given x raised to 4 minus 81 upon 2x square minus 5x minus 3. So again you have to split this because this also goes to 0 by 0 form. Okay. So we can write this x raised to 4 and this is 81. So this is 9 square and this is x square square. So I can write it as minus 9 x square plus 9. Okay. I took this as x square square. Okay. This you have to take factors 3 to the 6 and 5 ones are 5. And it won't be 5 ones are 5 also. Minus 6 and minus 5. 3 to the 6 is not coming 5. 1, 4, minus 6 and minus 1. Again we can use here a square minus b square. So this will be x minus 3, x plus 3. And this is 2x. Okay. So you'll get here 2x plus 1 into x minus 3. So this gets cancelled. Then you have to put 3. 3 plus 3, 6 into 3 square, 9. 9 plus 9, 18. 3 to the 6 plus 1, 7. Okay, so you'll get around 108 by 7. Next question, limit as x tends to 0 ax plus b upon cx plus 1. So putting x equal to 0, you will get here b. Answer is b. Okay. Limit as z tends to 1. Z is to 1 by 3 minus 1 upon z is to 1 by 6 minus 1. Okay. So when you put 1 here, you will get 0 by 0 form. So we have to reduce this. So we can reduce this in the form some x is to n minus 1. Okay. So I can put this, we have to put as x, correct? So z is to 1 by 6 as x. So what will be z? If I take this as z is to 1 by 2 into 3. So I'll write this 1 by 3. So it will be z is to, okay, 3 I'll take inside and 2 outside. So z is to 1 by 3 is x square. Okay, this goes here. Now changing the limits, as z tends to 1, x also tends to 1. Okay, so I can write this square minus 1 upon x minus 1. So using that formula, n a raised to n minus 1. So 2 is the answer. Okay. Next question. So putting x equal to 1, we'll get here a plus b plus c on c plus b plus a. So same thing, you will get 1. Okay. Limit as x tends to minus 2. So this is 1 upon minus 2. So 0 by 0 form. So again we have to reduce. So if we cross multiply, we'll get here 2 plus 1 by 2x, x plus 2. Actually this is 3. Oh, sorry. 2 plus x. So we can cut this. You will get 1 upon 2x. So substituting x, you will get 1 upon minus 4. So when you put x equal to 0 here, sign 0 is 0 and you will get 0 by 0 form. So we have to make use of the trigonometric limit here. We have to divide and multiply by ax. Okay, so that as limit x tends to 0, this becomes 1. So the final answer is A upon B. Okay. Next question, same thing. Again, you have to divide and multiply. So sin ax upon ax into ax. Sin bx upon bx into bx. Okay. So this thing becomes 1, this thing becomes 1 as x tends to 0. So the final answer is A upon B. So when you substitute here x equal to pi, so this is sine 0 which is 0. Here also it is 0. So this becomes 0 by 0. So we have to do some substitution here. Okay. So I can take pi minus x at some y. Okay. So when x tends to pi, y tends to 0. Okay. And what about x? Pi minus 1. So limit as y tends to 0 sine y upon pi, we have to substitute, right? Not x. Y plus, no need to substitute. Pi is here, pi into y. So as y tends to 0, this becomes 1. So your final answer is 1 upon pi. Next question. Limit as x tends to 0. Cos of x upon pi minus x. So cos 0 is 1. Pi minus 0 is pi. So final answer is 1 upon pi. Some questions are direct. Cos 2x minus 1 upon cos x minus 1. So here if you put 0, cos 0 is 1. 1 minus 1, 0. So this becomes 0 by 0 form. So you have to reduce this. So here I can make use of the trigonometric limit. Okay. You can write this as we have limit as 1 minus cos x upon x as x tends to 0 is 0, correct? And 1 minus cos x upon x square is half. So here we can write this as 1 minus cos 2x minus sign right outside upon 2x into 2x. Then minus 1 minus cos x upon x into x. Okay. Okay, so this goes to 0 actually. We have to make use of half angle formula. Cos 2x minus 1. So 1 minus cos 2x, cos 2x is 1 minus 2 sin square x. And for this you have to make use of half angle, that is 1 minus 2 sin square x by 2. X cancel, this gets cancelled. This underscores, we'll get sin square x upon sin square x by 2. Now we can make use of trigonometric limit. So this becomes sin square x upon x square into x square. Okay. What about this? Sin square x by 2 upon x by 2 the whole square into x by 2 the whole square. Okay. Whenever there is a square, you have to divide and multiply by the square of that angle. Okay. So you'll get here this becomes 1, this becomes 1. So x square upon 1 upon x square by 4. So final answer is 4. Okay. Question 18. Limit as x tends to 0, ax plus x cos x upon b sin x. Okay. When you put x equal to 0, it becomes 0 by 0. So we have to reduce this. You can take common x. Here we can make use of x tends to 0. So I'll divide and multiply. So this becomes 1 as x tends to 0. Okay. And this x and this x gets cancelled. We have a plus cos x upon b. So when cos 0 is 1, so we will get a plus 1 by b answer. Okay. And I put this as 0. This is not defined. So this is 0 into that thing. So 0. Yeah. Cos 0 is 1. So sec 0 is 1 upon 1. So this becomes 0 into 1, which is 0. Okay. Next question. So put x equal to 0. This is 0 by 0 form and 0 is 0. Yeah. Here we can divide and multiply sin ax upon ax into ax, okay, plus bx upon ax plus sin bx upon dx into bx. So this becomes 1, this becomes 1 as x tends to 0. So we'll get here limit as x tends to 0, ax plus bx upon ax plus bx. So this is 1. So this is as x tends to 0, sine 0 is 0. So this will be 1 upon 0. So this is infinity. What about cot 0, 1, 0? So tan 0 is 0. So this will be 1 upon 0. Again infinity. Okay. So we have to reduce this. Cosec of x, I can write 1 upon sin x. This I can write 1 upon tan x. So we can make use of this. So I'll write divide by x into x, divide by x into x. So this goes to 1 as x tends to 0. So we'll get, oh, we are getting 1 minus x minus 1 upon x, correct? This is, we are getting 0. This is fine. The answer is 0. Next question. Limit as x tends to pi by 2, tan 2x upon x minus pi by 2. Okay, so when your x goes to pi by 2, tan of pi, 0, 0 by 0 form. So we have to reduce this. So put this thing x minus pi by 2 as some h. Okay, so x is h plus pi by 2. As x tends to pi by 2, h tends to 0. So limit as h tends to 0, tan of 2, x is h plus pi by 2 upon h. So this we can write 2h plus pi. If I take this inside, this becomes 2h plus pi. So pi plus some angle. It is in the third quadrant. Third quadrant, tan is positive. Okay. And pi is there, so no transformation. So we'll get here limit as h tends to 0, tan to h upon h. So we have to make this equal. So into 2 divided by 2. So this becomes 1. Answer is 2.